So looking again at trying to be able to plot lines using the y equals mx+c method, or the y-intercept method, there's a few special cases that we have to be aware of, and really just the two. There's a horizontal line or a vertical line. And they're kind of slightly different in the fact that you don't see something that looks like y equals mx+c, like we are getting used to finding or using for the graphing these. But in the first one, the horizontal lines, you'll notice that you're actually missing the x term altogether. So in a sense, you could kind of imagine that as being a gradient of 0. Like you're saying y is equal to 0 times x plus 5. So in fact, 0 would mean no gradient. There would be no gradient at all. So it just becomes a straight line. I mean, a horizontal line, because it's not rising. There's no rise. There's 0 rise. So horizontal lines you'll always see written as y equals some number. So in this case, y is equal to 5. So horizontal line at y equals 5. Well, literally that means that y is equal to 5 everywhere. I don't care what x is. I'm always going to have y equal to 5. So you could think about just an infinite number of points along y equals 5, or just putting that line straight across there. Y equals 5. So again, it doesn't matter what value of x I have, my y is always equal to 5. It makes a horizontal line, but I'm saying that I know anywhere on that line y is equal to 5. It's one thing that never changes. In the next example, y is equal to negative 3. Same idea. Anywhere on this line y will be negative 3. Does not matter what happens to x. My y never changes. So here I'll end up with y is equal to negative 3 as a horizontal line along negative 3. Y equals 0, meaning that y is equal to 0 anywhere I go. And that happens to be right along the x-axis. So y is equal to 0, meaning the value of y anywhere along there is 0. I'm always on that x-axis. Vertical lines, the format is written out differently in the sense that here you'll notice instead of y equals blah 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 like we've had for the last two cases, it's now saying x is equal to something. And it's kind of similar to horizontal lines in the sense they describe that y never changes, it's always the same value, so it's going to be a horizontal line. The vertical lines here kind of are saying the same thing. They're saying, oh, well, in this case, x is equal to 2, and it never changes. So let's see where x is equal to 2. That's here, and here, and here, and anywhere along that line, x will be equal to 2. So if I have to plot x equals 2, it is literally everything along that line. So x is equal to 2. It's going to give me a vertical line where every single point on that line has x equals to 2. So I don't care what y is, because x never changes. For y equals negative 5, again you can go to the negative numbers here. Sorry, x is equal to negative 5. We're going to go out to negative 5, and we're going to put in a vertical line. And that's x equals negative 5. It's always negative 5. And x equals 1. Finding x equals 1. Not a very straight line. That's x equals 1. So the horizontal and vertical lines, just remember that horizontals are always going to be y equals, and the verticals are always x equals, and that it will never change. And if you're having a hard time remembering horizontal and vertical, one thing that you can think about is that horizontal has the word very similar to horizon in it, meaning when you look out across the Canterbury Plains, you see that flat horizontal line, the flat line of the horizon. So that's one way to help you remember that.